Exercise 7, ratios and proportions. A ratio is a relationship or a comparison between two quantities. What we're going to be talking about here with ratios and proportions are very, very important uh, concepts that you will see on every single ACT test. You don't always necessarily need to use proportions to solve problems, but there are probably usually between 4 and 6 problems on every single ACT that could be used solving a proportion. Proportions are pretty simple to work with, okay? Most of you know to solve a proportion, you cross, multiply, divide, and that's how you've had it memorized since you were in middle school, which is the case. So if you can just set up the proportion, there's a handful of problems, like I said, 4, 5, 6 on every ACT that can be solved using proportions. Ratios can be written in 3 ways. Let's say that a class has 18 girls and 12 boys. There's 3 different ways that we can express that ratio. We can write it as 18 with a colon and then 12. That is read as 18 to 12. We can write it out in words with the word 2, 18 to 12, or we can write it as a fraction, which looks like 18 over 12, which also could be read as 18 to 12. This is the form that is going to be most useful for us because that is the same form that we're going to use then when we go to begin setting up proportions. Proportions, or ratios, I'm sorry, should always be written in simplest form. So these first 3 ratios up here, 18 to 12, both numbers can be divided by 6. If I do that, the ratio simplifies to 3 to 2. And again, we have all 3 different ways in which we can write it. I think reason being not only for proportions, but if we get used to writing them as fractions, you've been ingrained to always give some fractions in simplest form. I think you'll remember then to simplify your ratios as well. Common ratios that we use in everyday conversation. Ratios, like I said, come up a lot on the ACT. They're also used a lot in everyday things that we talk about. We just don't usually think about it as being a ratio. Your car gets 24 miles per gallon. That is a ratio. It's a ratio of 24 miles per 1 gallon of gas. You go to the store, there's a lot of things that you can buy by the dozen. Sometimes the prices are given by the dozen, even though you can buy less than a dozen. $5 per dozen means that it would cost $5 for 12 of that item because there are 12 things obviously in a dozen. So those are types of ratios that we use every day. There's a lot more. But again, ratios and proportions, important aspect of the ACT. Okay, using ratios here to divide quantities. We have a $750 prize that is to be divided up in a ratio of 3 to 2 between the top 2 finishers in a contest. How much money will each person receive? So what we're looking for is in this sentence right here. How much money will each person receive? That's what we don't know. In place of something we don't know is when we use a variable. Okay, so let's let x be our variable. Okay, and so in this case we have 3x plus 2x. Okay, one person is going to get 3 times as much as the other one, but we know the total prize money has to equal $750. Add those together. We get 5x equals 750, divide, and we get x to be 150. So x is 150. That's the amount in each piece that each person is going to get. The first place person is going to get 3 of those pieces, or 3 times 150, which means they're going to receive $450. Second place is going to get 2 of those pieces of $150 chunks, which means they're going to get $300. Okay, proportions. Simple proportion here. Proportion is made up of 2 ratios that are equal to one another. So proportion and ratios obviously are very much related. When you have 2 ratios that are set equal to each other, that's when we have a proportion like we have here. You've been taught to cross multiply and divide. You really don't necessarily need to do that. You're adding in a step when you do that, especially if what you're solving for is up here in the top like it is here. I'm trying to get x by itself. So I'm going to leave x right where it's at. X divided by 70. Opposite of dividing by 70 is to multiply by 70. So I'm going to multiply both sides here by 70. Leaves me with x, which is what I wanted. In your calculator now, plug in 70 times 5/14, and you should get 25. Had you cross multiplied and divide, you're still going to get to the same answer. So let's do it that way as well. Cross multiply. 5 times 70 is 350. X times 14 is 14x. Divide by 14, and you're still going to get x to be 25. So either way, you're going to get to the right answer. If what you're solving for is up in the top, you don't need to necessarily cross multiply and divide. You can simply get the variable by itself. Setting up our own ratios to solve, or our own proportions to solve. Cost $65 for 24 gallons of gas. How much would it cost for 15 gallons of gas? So this is a ratio that is linking two things together. In this case, the cost for the gas versus the number of gallons of gas we get. We want to know how much would it cost. If possible, whatever you are trying to solve for, put up in the numerator. So in this case, how much would it cost? There's our variable. Let's call it x for 15 gallons of gas if we know that it costs $65 for 24 gallons of gas. However you set up your one ratio, you must set up the other one the same way. So in this case, because I went dollar amount over number of gallons, when I set up my second ratio, I have to go dollar amount over the number of gallons. It doesn't matter if you have those switched as long as it's switched in both ratios. So had I gone number of gallons over dollars, then I would have to go number of gallons over dollars in my second ratio. Solve this for x. Multiply the 15 to the other side. So you're taking 15 times 65 over 24. Round, we're talking dollars and cents, so round to two decimals, we get $4 or $40.63. And that is it.